My name is Andre Faria, and I'm a Senior Technical Account Manager here at AWS. In this video, I'll showcase how to work with self-managed Active Directory within Amazon Relational Database Service for SQL Server. In case you're unaware, you can join an Amazon RDS for SQL Server database instance to a Microsoft Active Directory domain. Your Active Directory domain can be hosted on AWS Directory Service from Microsoft Active Directory, or, as of July 2023, you can also join your RDS for SQL Server Instances to a self-managed Active Directory in a location of your choice, including corporate data centers, AWS EC2, or within other cloud providers as well. Prior to July 2023, if you want your on-premises users to have access to your RDS for SQL Server database instances, you'd have to set up a trust between your AWS Managed AD and your on-premises AD in order to be able to delegate those users and set up logins for them within the SQL Server environment. Now, with the self-managed AD option, you can use any AD environment given that you have a network path that allows connectivity. Let's go over a few deployment differences that you'll notice when using the self-managed AD support option when compared to using AWS Managed Microsoft AD. First one being that Secrets Manager secret encrypted with a customer managed key is required. Also, the service account has to be stored in a secret, meaning that if you rotate passwords for your service accounts, you'll need to ensure you update the secret within Secrets Manager as well, in order to keep the values in sync and avoid breaking the service. Finally, it's also worth noting that during the deployment steps, you'll have to specify DNS servers in order to resolve the Active Directory domain. As for operational differences, you won't notice any from a SQL Server perspective. However, it is worth highlighting that once you complete the deployment, you should not move or rename the created RDS Active Directory objects, as this will break the service. In regards to recommended practices, in order to decrease blast radius, do not use the same service account for all of your Amazon RDS for SQL Server deployments. Having a single service account for multiple SQL Server deployments could potentially affect all your deployments in the event of a compromise or misconfiguration. Our recommendation would be to create a separate service account per application that the SQL Server instance is being used for. The same applies to the target OU. The service account requires permissions to the OU where the RDS object will be deployed, meaning that if you have multiple service accounts targeting the same OU, they could all potentially affect objects within that OU. An OU per service account would be the best practice. The service account should also be limited only to the OU within the limited permissions that we prescribe. Providing elevated permissions to the service account, such as domain admin, should be avoided in order to not over-provision that service account. As for DNS, ensure that you keep the target IPs current. So for example, if your DNS is integrated with Active Directory and you replace the domain controller and update its IP address, ensure that change is also reflected within your RDS configuration. And finally, keep the password for the service account which is stored in the secret and its AD object counterpart in sync with each other. This is important to remember if your company's password policy enforces a certain expiration date. Let's now dive into the demo portion, where we'll be creating an Amazon RDS SQL Server database instance, join it to our on-premises AD, and then connect to it with our on-premises domain credentials using Windows Authentication. We'll start off by configuring our on-premises Active Directory. Connect your AD domain as domain administrator and open up Active Directory users and computers. Now select the domain where you want to create your OU, right-click the domain and choose New, then Organizational Unit. Enter a name for the OU. In this scenario, I'll be using AWS RDS. Once you're done, click OK. Now with our OU created, we'll move on to creating the service account to be used by our Amazon RDS SQL instance. Within Active Directory users and computers, select the domain in OU where you want to create your user. In this scenario, I'll be creating the user within an OU called Domain Service Accounts. Right-click the OU, choose New, then User. Now enter the full name and user login name for the user. In my case, it'll be svc_RDS. Once you're done, click Next. Now enter a password for the user. Deselect the user must change password at next login option, then click Next. Click Finish and confirm that your user now appears within the desired OU in your domain. We'll now delegate control to the AD user account within our domain. Within Active Directory users and computers, right-click on the OU you created earlier and choose Delegate Control. Within the Users or Groups section, click Add. Now enter the AD user you created earlier and click Check Names. If your AD user check is successful, click on OK. Now within the Users or Groups section, confirm your AD user was added, then click Next. On the Task to Delegate section, choose Create a Custom Task to Delegate and click Next. Within the Active Directory Object Type section, ensure that you select the Only the following objects in this folder radio button. Then ensure that you have the Computer Objects checkbox selected. After that, also ensure that you have both the Create Selected Objects in this folder and Delete Selected Objects in this folder checkbox selected. Then click Next. On the Permissions section, keep General selected, and also select the Validated Right to DNS Hostname and Validated Right to Service Principal Name checkboxes. Then click Next. Review your settings, then click Finish. We'll now create the KMS key used to encrypt our AWS secret. Within the AWS Key Management Service console, choose Create a Key. You can leave the default options for both key type and key usage selected, then click Next. For alias, provide a name for the KMS key. In this scenario, I'll use RDS Self-Managed AD. Within the Define Key Administrative Permissions section, type in the name of the administrator, select it, then click Next. Ensure that you leave the Allow Key Administrators to Delete this key checkbox enabled. Within the Define Key Usage Permissions, type in the name of the same administrator, select it, then click Next. Now review the configuration. For key policy, include the following to the policy statement in order to allow use of the KMS key on behalf of RDS. Once done, click Finish. With our AWS KMS key created, we'll now proceed to create our secret. Within AWS Secrets Manager, choose Store a new secret. For secret type, select Other type of secret. For key value pairs, add your two keys. For the first key, enter Customer Managed Active Directory username. For the value of the first key, enter the name of the AD user that you created on your domain in the previous steps. In my case, SVC RDS. For the second key, enter Customer Managed Active Directory password. As for the value of the second key, enter the password that you created for the AD user within your domain. For encryption key, enter the KMS key that you created in a previous step, then click Next. For secret name, enter a descriptive name that helps you find the secret later. In this scenario, we'll be using Secret RDS. Now for resource permissions, click Edit and add the following policy to the permission policy. Ensure that you use your own account within AWS Source Account and AWS Source ARN. Now once you're done, click Save, scroll down, and click Next. For configure rotation settings, keep the default values, then choose Next. Review the settings for the secret, then click Store. Now choose the secret you created, then copy the value of the secret ARN. This will be used in the next step to set up Self-Managed Active Directory. We can now proceed with creating our Amazon RDS SQL Server database and associate it to our self-managed AD domain. For this demonstration, we'll be using the AWS CLI to create our database. You can create your databases using the AWS console RDS API as well if you prefer. When you use the AWS CLI, the following parameters are required for the database instance to be able to use the self-managed Active Directory domain that you created. For the domain FQDN parameter, use the fully qualified domain name of your self-managed Active Directory. For the domain OU parameter, use the OU that you created in your self-managed AD. For the domain auth secret ARN parameter, use the value of your secret ARN that you created in the previous step. And finally, for the domain DNS IPs parameter, use the primary and secondary IPv4 addresses of the DNS servers for your self-managed AD. With our database created, we can now create a SQL Server Windows login for our test user to be able to connect. Connect your database instance using the master admin account and run a data definition language command such as the following example in order to create a SQL Server login for an Active Directory user or group. In this case, we'll be creating a login for the test user under our local domain. Now with our login created, we'll connect to the SQL Server instance as test user. To connect the SQL Server with the Windows authentication, you must be logged into a domain-joined computer as a domain user. Launch SQL Server Management Studio, insert the name of the RDS instance within the server name text box, and ensure Windows authentication is selected as your authentication type. Once that's done, click Connect. You're now connected to your RDS SQL Server using Windows authentication from an on-premises domain. I hope you enjoyed this session and learned something new. Thanks for watching, and until next time.